The line for recycling of cooling and refrigerating equipment serves the purpose of material recovery of electrical equipment items unsuitable for further use. Disused cooling equipment items are supplied from users to storage areas of the processing company. Upon inspection of the appliance, the power supply cable is disconnected and the refrigerator is placed on the transport conveyor belt. Cooling media are removed from the cooling circuits with the use of special tools. The refrigerator must be tilted during this process in order to ensure that the cooling medium and oil are completely removed. The subsequent step involves the dismantling of the compressor. The cooling medium is then separated from the compressor oil in a separating device, and both substances are placed in storage containers. From absorption refrigerating machines that are based on the use of ammonia, this is removed on a special separating device that also serves as a mobile unit. The crushing of refrigerating machines is done in a chain mill. Refrigerating machines are crushed to obtain smaller pieces, which are then transferred to drier screw conveyors. Heat applied here results in evaporation of water and other hazardous substances contained in the refrigerator insulation, such as CFC and pentane. Nitrogen, which can absorb other gases, is blown inside the screw conveyors. Solid pieces are separated from the crushed pur foam in a screening machine. Solid fractions are then transferred to mechanic separation. Separation of ferrous metals is done inside a magnetic drum. This separation allows very pure scrap iron, free of any non-metal contaminants, to be obtained. Non-ferrous metals are separated from plastic materials in a vibration separator based on the use of eddy currents. With the use of this separation technology, we can also separate non-ferrous metals such as aluminium and, in smaller quantities, also copper. This is an excellent input material for production of aluminium alloys. Crushed pur foam with the contents of residual freons. This passes through a system of matrix conveyors. Owing to high temperatures, residual freons change back into the gaseous state and are absorbed by the nitrogen atmosphere. The purified pur foam is then trapped into large volume big bags. The use of a so-called cryocondensation unit then provides for the isolation of freons from nitrogen. Liquefied freons are then collected into special presser vessels and transferred to the disposal site plant. Material recovery from mercury-containing electrical waste. The crushing and separation line for material recovery from fluorescent tubes. The line has two openings through which tubes may be loaded into the machine. One for manual loading of intact tubes and one for manual loading of compact fluorescent tubes. Inside the machine, tubes pass through the system of crushing and separating components. The entire inner area of the container has negative pressure to prevent any mercury from being released into the atmosphere. Crushed glass is transferred through the dedicated opening into the container for collection of glass. Crushed metal fractions are then transferred to the separator of metals to separate ferrous and non-ferrous metals contained inside the equipment being scrapped. Fluorescent dust is collected in drums placed under the cyclones and filtration system. Separate fractions of fluorescent dust are intended for further processing in a special distilling apparatus. CFL lamps, or non-linear shaped lamps, such as 2D lamps for example, as well as broken linear fluorescent lamps, are then transferred with the use of a manually rotated transferring mechanism into a crushing conveyor. The crushed lamps pass through a system of screening devices where plastic sockets are separated from glass material. Plastic sockets are transferred to the collection container for storage of plastics. Glass and dust particles will be transferred with the use of a pneumatic transport system to the compact processing line. Equipment for processing of high-pressure discharge tubes. This serves for the processing of HID lamps of a variety of types and sizes. The first step includes crushing of outer housing. Outer housing glass particles are then separated from the arc tube and metal base. Glass fractions are transferred through the opening for glass unloading into a storage container. Metal bases are transferred and collected automatically outside of the processing plant into a container for metals storage. Glass from arc tubes and contaminated metals will be further processed in a special distiller. This machine enables the extraction of mercury fixed in luminescent dust and the separation of mercury from arc tube glass and contaminated metals through a number of sequential steps carried out at specific levels of temperature and pressure, thus restoring its original condition prior to its use for production of light. Electrical waste processing line. The first phase of recycling involves the manual dismantling of electrical equipment. The purpose of dismantling is the need for prior removal of any material containing hazardous substances. TV cathode ray tubes, which contain hazardous luminescent dust, are first transferred to the dismantling area. Here the cathode ray tube is unsealed, the metal screen dismantled, and hazardous luminescent material removed with the use of a special vacuum cleaner. Following the accomplishment of these steps, the cathode ray tube stripped off in this way is placed on a container and is ready for further processing. Electrical waste is subject to prior removal of the following substances and parts: capacitors and electrolytic capacitors, parts containing mercury, batteries, PCBs, toner cartridges, cathode ray tubes, gas tubes, and liquid crystal displays. Electrical waste processed in this way is then placed into a container from where it is transferred by the belt conveyor onto the vibration trough that continuously feeds the material into the chain mill. In this mill, rotating change crush it into small fractions. Dust particles are removed through an exhaust system. Greater size particles fall first onto the conveyor belt, on which they are transferred through a magnetic separator which traps the solid iron particles. Other metals and plastic materials are transferred into a drum separator. Particles smaller than 100 millimeters are subsequently fed for further processing into a hammer mill. Greater particles are separated magnetically, iron fractions of various sizes being trapped here again. The remaining particles of greater size transfer to a belt of a separate conveyor. Here the personnel manually separate various materials such as aluminium, copper, brass, as well as other materials that need not be processed further with the use of mechanized equipment. The remaining waste is subsequently fed into the hammer mill. Electrical waste is loaded in the feeder silo, from which it falls down onto the belt of a feeder conveyor. Subsequently, the fed material is separated in a vibration trough. Material is further fed into a twin-rotor hammer mill, where it is crushed into small fractions. With the use of an exhaust system, small dust particles are removed and transferred into a separator. The remaining particles are fed into separating equipment in the form of a drum separator that removes the magnetic fraction from the waste. The remaining waste, such as aluminium, copper, silver, plastic and ceramic materials, are fed to sizing screens to obtain the 3 separate sizes of fraction that are placed into the pallet storage containers. The next step of processing includes separation by air. Scrap falls into a vibration trough with magnetic separation and onto a feeding belt conveyor, from where it is dropped into the air separator. In this separator, the heavier fractions are separated from those that are of lighter weight. The remaining dust particles pass through filtering and are collected into the so-called big bags. Heavier particles of non-ferrous metals are separated here from the lighter particles of mixed plastic materials and collected in prepared pallet containers. Processing of electrical waste with the use of electrostatic separation. In this phase, electrical waste is separated with the use of electrostatic separation. The equipment is operated using a variety of frequencies upon which the separation of metals from plastic materials is based. This step involves the separation of the following 3 types of waste: non-ferrous metal waste, mixed metal and plastic material-based waste, to be separated in a sequence of repeated steps, plastics waste material intended for subsequent